Am I audible to everyone?
Yes.
Yes, you are.
Okay. I would like to start the session by citing a Bible verse from the book of 1 Peter chapter 4 verses 10. Each one, as a good manager of God's different gifts, must use for the good of others the special gift he has received from God. So a very blessed morning and warm welcome to Code for Christ. Code for Christ is a Tech Talk series initiative by the Tech Ministry of Jesus Youth Infopark. So we, the members of Tech Ministry, are a Christ-loving community of developers who create coding projects to glorify God. So far we have developed 3 projects. One is a website called catholicstreams.in, where all the online masses are listed. And then we have developed a Chrome extension called a Word Box. It displays the Word of God in every new tab. And currently we are developing a contact management system for Jesus Youth called Raphael. So now let me introduce the presenter of the Tech Talk, Mr. Arun Mathew. He is working as a senior backend engineer at Inspirit Chennai. I warmly welcome you. So let's start this session with a prayer. O loving Father, we entirely submit this initiative and the presenter into your hands. Please help us to stay attentive and to use it effectively. We pray for every member participating and for their family. We humbly surrender our tech ministry to use it for your glory and honor. Amen. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven.
As we forgive those who trespass against us.
Forgive our sins as we forgive those who sin against us. Lead us not into temptation, but deliver us from evil. For thine is the kingdom and the power and the glory forever. Amen. Hail Mary, full of grace, the Lord is with you. Blessed are you among women. Blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sins, now and at the hour of our death. Amen. Over to you, Mr. Arun Mathew.
Thank you, Rincy. Sure. I'm just going to share my screen. Hope all of you can see my screen.
Yes, sir.
Yeah. So as Rincy introduced, so my name is Arun Mathew. I'm working with Inspirit. We are a tech startup based out of Chennai. With that, we'll get into the agenda today. So this talk is about serverless computing. It is more geared towards beginners. So just to understand the concept of serverless computing. Hopefully in future, we'll have more advanced talks. So we'll start off with the beginner level today. Yeah, and on a very high level, this is what we are planning. So we'll first go through the evolution. How did we end up with serverless? So what were the previous technologies, or what are the previous patterns that are available, and what is serverless? Then we'll have a small demo. So a small demo in the sense we can equivalent to creating a hello world API. So we'll create it in the serverless world, and we'll try to access it from internet and see how it works. After that, we'll look at a real world example, an architecture that is very popular nowadays. A simple one, it can be, I mean, definitely there are more possibilities, but we'll keep it simple today. After that, we will just go through the benefits and drawbacks of this approach. And throughout this presentation, if there are any questions, please feel free to put it in the chat, or at the very end, we will have a Q&A section. So you can, if you want, you can unmute and talk as well. But as you go, if you have something, you can directly put it in the chat and we'll address at the end. Cool. So I think we're good to get started. So the very first thing, we'll go through the evolution, like how did we end up, or what is this new paradigm called serverless? So I'm pretty sure all of you know this approach, but just refreshing to give you some context. So the traditional approach, so even before cloud came into play, what the traditional approach was for companies to buy, have dedicated data centers. They have dedicated servers like web server, application server, database server. So this was the typical approach prior to cloud, and this is even valid today in a few other domains like finance, fintech, certain fintech banks, etc. So the downside, of course, which probably we all know, is one is getting new servers, or scaling. For if say your application is growing and you want to get new servers, it's a very difficult process, or it's a time consuming process. The capital investment here is very high because you are actually investing for your future, but we're unsure actually if you will need those many servers or not. So say you buy 10 servers, but you end up only using 5, the remaining 5 remains there. So the capital investment is difficult, is more here. And then you own this entire process end to end. So this was the, I would say, at least in India before 2010 or 2011, this is what the traditional approach was. The next progression was the cloud approach. So a lot of cloud players came into play. So starting with Amazon, that is Amazon Web Services. Now we have Azure, we have Google Cloud, and other smaller players too. So when the cloud, cloud platform or cloud approach came into play, things changed a bit. So the very first change was a lot of these traditional components, right? Like maybe a load balancer or an application, a particular server. So the cloud provider started giving them, renting out their servers as virtual machines to end users. So the natural progression, the very first step, what people did was, okay, they realized that, okay, I no longer have to own a data center. I can rent out my servers from Amazon or any of the cloud, cloud players. And it inherited a lot of advantages as well. For example, you can say, you want 5 servers for a particular, or you want to scale out your servers for a particular sale. You pay only for that servers for those 5 days. After your use is over, you can terminate it. So you got that elasticity. And now, at least theoretically, now we have unlimited access to unlimited CPU and unlimited storage. So it's all about how much money you want to spend. So you don't have to spend money that is, or buy something that you don't require. So the limits here are kind of infinite if you have money. So this was a natural progression. So first, people from the traditional approach, people started, instead of buying from having dedicated data centers, people started renting out servers from the cloud providers. Now, throughout this, like with the first approach, with the cloud approach, one thing to always note is we are actually, so when you rent out a server from, say, Amazon or any of the cloud provider, you are owning that, or they are allocating that server for you, and you are paying for the entire life, for the duration that you're using that server. So say I have a website which is maybe has a traffic of maybe 10-20 people maybe accessing that website every day, but you're paying for that server the whole time. So it's kind of if you look at the tenancy here, you're getting a dedicated server and you're paying for the entire lifetime, though you're having only 20 or 30 requests. So you're forced to do that because you're having the cloud provider is giving you a dedicated server. So as things, as this approach became very popular, and as the cloud providers started evolving and introducing new services, the natural next progression here was something called serverless. So one thing to always note here is, though the paradigm is called serverless, it is not actually serverless. You still have servers. It's only that you no longer get access to the server, and it's a change in your mindset. So it's you don't have a dedicated server. Instead, you focus on your program and give this program to the cloud provider. So it's a responsibility of the cloud provider now to start your application and handle the operating system, do the security patches and everything. One point that I missed earlier was, even in the old cloud approach, you are still responsible for patching your servers. It's a shared responsibility model. So you are responsible for doing security patches and stuff like that. Whereas in this paradigm, that is the new serverless paradigm, you in your world as a developer or as a company in your world, it is only about your program. Rest everything is managed by the cloud provider. So one main change here is in the pricing model. So the pricing model for all the serverless technologies are you basically pay per request. So if you look at the previous example that I just discussed, so I have a website which is getting say 10 to 20 hits per second. In the previous model, you still have to, you need to at least have one instance of at least one server up every time so that your customer is able to access, right? So you're paying for that server 24/7. Whereas in this model, you only pay for that 20 request that you're processing. So only when people hit your website, that's the only time you're paying the cloud provider. So in that way, it is a lot cheaper. And there are also other terms. So serverless is also known as event-driven. It can also be called event-driven, which you'll get more context why it's called event-driven when we look at the demo. And another way, it's also known as function as a service. So so the whole point is you are totally focused on your application, your business logic, and you're not worried about anything else. That's why it's called function as a service. And typically, serverless functions are written in a microservice pattern, which is very small functions. Yep. With that, one thing I wanted to note here is so all these you see AWS, so the Lambda function, right? This is the AWS Amazon Web Services terminology for serverless function. You will find the same thing in other providers too. For example, in case of Azure, you'll find Azure functions. In case of Google Cloud, you'll find Google Cloud functions. So this is purely, I mean, all major players have equivalent services or equivalent serverless offerings. It's just named differently, and the features are a bit different. Cool. So with that, let's do a small demo. So the goal of this demo, basically, if you want to do this, you want to explore this, you'll need an Amazon account, which is a prerequisite. So starting an Amazon account is all you need is a debit card. So it's mandatory that you provide the payment details. But from once you have created an account, doing this demo or following these steps shouldn't cost you anything, because you get a lot of, so with Amazon or almost all other cloud providers, you get a free tier or a trial period wherein you can play with explore the services. So probably you'll have to Google. I mean, opening an account in Amazon Web Services is very straightforward. It's just like signing up for a new email account. So with that said, what we're trying to do here is we'll just create a simple API, say a kind of hello world API, and we'll expose it to internet, and you can actually hit it from you guys can start calling it from your mobile and see how it works. So the whole our objective here is just to get a sense of a feel of how easy it is to do serverless functions or to actually deploy it. So with that, so the very first thing, once you sign up, once you have an Amazon Web Services account, this is how the console looks like. On the top bar, you need to search for a service called Lambda. So as I previously mentioned, that is the name of the service, the serverless offering from Amazon Web Services. So once you select Lambda, you will be greeted with a screen like this saying that you have 0 functions. So we'll go ahead, select create a function, and that would take us to the screen where they actually provide a couple of options. Like, do you want to create a function from scratch? Do you want to use a blueprint that is Amazon has a couple of samples that if you want, we can explore, and a couple of other examples. Just to keep things simple, we'll just do something from scratch. We'll stick to the bare basics today. So we're going to select, create a function from scratch. The very first step is you need to provide what you want to call your function. So let's call it a random string. So the goal here is we will have a function that will just return us random strings. That's it. Then you need to select what runtime. So runtime in the sense, what language are you going to write this program in? So there are a couple of almost all popular program platforms are supported. So we'll go with Python for this example, and we can keep. I'm not going through the other settings because it's not valid for this demo, but we'll just keep it simple and just select create function. So we'll give it a couple of seconds. Okay, so now that we have this function, now a function, so I want to just go through that concept once. So a function is nothing but your program. Now, running your programs alone in alone in the server doesn't expose it, right? Or for example, you have a private server and you've written a program that is running inside it, but you want the outside world to access it. For example, in this demo, we want all of us to be able to hit it. So there's a concept called API gateway, which is, as the name specifies, it's an entry point for traffic from outside world to your function. So to actually do that plumbing, now that we have a function, which is a sample function, we are yet to code it, but we have that function. So, but we want to add a trigger. We want to have the connection, outside. We want a connection from the outside world to this function. So we will select add trigger here. So Amazon provides a lot of triggers. We will stick to API gateway because our goal here is to create a API. So we'll select API gateway, and Amazon will ask us, what kind of API gateway we want. We are going with HTTP API, and it will also ask, is this API open, or do you want to secure this? Is it do you want to have authorization around this API or authentication? So in this case, we'll keep it simple. We're just opening it up so everyone can hit it, and we'll just select add. So this is a step where we are connecting the outside world to our function. That is API, and this API gateway terminology is nothing but it's the name of the service that Amazon provides. So again, the same concepts are true for other providers too. Now that we have that, so when you scroll down, you can see we have a trigger, and that's an API gateway. If we select on the details, we can see that Amazon is providing us an endpoint. So this is the URL that we'll be hitting after we write our business code to reach this function or to trigger this function. So let's copy this and keep it on a notepad so we can come back to it. So now that we have a function and we have the plumbing, all the integrations connected, now let's focus on our business code. So we'll go to the code tab. And if you scroll down, there are two ways people normally use. So typically you write the business log or you code in your local system and then upload it to Amazon, which is the most popular way. Just to keep, since we have a very simple function here, we'll use the inbuilt code editor for this demo. So I can show you how to upload it. So say you're doing it from your local system, you can select upload from and then upload your package, upload your code as a zip file. So that's the way, the most popular way, I would say. But to keep things simple here, we'll just use the inbuilt editor. So you can see that Amazon has already created some boiler code for us. So I want to tell something, focus something on is this particular function. So called Lambda Handlers, the signature of this function. So so Amazon actually, so whenever you upload your custom code to Amazon, Amazon expects your custom code to adhere to certain prereqs. For example, if you're uploading a Python package, it expects your Python code to have a function called Lambda Handler. This is because it is kind of mandatory because so that Amazon can it understands that, okay, the Lambda service understands that this is your main entry point. So you can just think of this as your main entry point to your application. It is possible to rename this, have a different name for the entry point, but you'll have to change few settings, which it's out of scope for this session. But out of the box, it expects a function called Lambda Handler with this particular signature. So behind the scene, what is happening here is whenever a user hits our API gateway, which is the URL, the integration that we created, Amazon calls or sends an event to this function, and the event that it sends is received by our business code under this event object, and there is another object called context as well. So event will have information like what was it, a get call, was it a post call, what was the source IP of the user who hit our API, and a lot of metadata around it. After some time, I will just show that how that event structure looks like. And the second information that you get is that Amazon provides to a function is context. Context is, as its name suggests, it gives you more information about contextual information about your function, like how much memory has Amazon allocated or is allocated for your program and stuff like that. So we won't focus on context today, but event is what I think is more interesting for us at this point. So it is basically information like, was it a get call, was it a post call, what was the source IP of the register, and everything related to that event. And that is why in my presentation I said that serverless is also typically called as event-driven architecture. So it's basically events, and only when an event happens, your function runs, and that is the model, the model here. So let's do a simple. We'll just first do a simple example, and then we will do a few iterations on top of it. So this is a sample code that Amazon has already given. So we should be able to hit this right away. And I'll put this in the chat. So you guys can see that if you hit this URL, which is our API gateway, it is now returning a string called hello world. Okay, now we'll just make some changes here. So say I want to return, so every time a user hits this API, I want to return some random Bible verses. So that is our goal here. So we'll just create a constant with some Bible verses. So ideally, you can store this in a database and fetch it from there too. But to keep things simple here, we'll just go with an array for now. And since we basically want to randomize, right? So we'll use a Python inbuilt library called random. So whenever whenever this function is called, we want to generate a random number. So we'll do a rand int. These are all native Python native functions that are available, nothing external. So we want a random number between the index 0 and the length of the array. So the length of the array will return you, since Python uses 0-based indexes, we need to -1. And instead of returning hello from Lambda, we'll now return a verse. So just to go through this once again, all we did is we introduced an array which holds our Bible verses. And then we want to generate a random number. So whenever the function is invoked, we get a random number between 0 and the length of the array. And then using that number, we pick a value from the array and return it back to the user. Cool. So now that we have made these changes, let's save we can save it using the inbuilt editor, and there's a button called deploy. So it really happens instantaneously. So that is one good thing of serverless world. You don't have to handle complex deployments. It's all taken care for you. So it even takes care of scenarios where, say, there are users using the old function. So it waits for the that functions to be released and then deploys the new code. So it takes care of all those typically ops heavy things.
Arun, you have a single quote in the first verse, so it could cause a problem, I think.
Yep, correct. Thank you. Is there something else? Hopefully, I will debug. Okay, let's change this. So let's try hitting this endpoint again. So now you can see things have changed every time. Even you guys can try hitting it. So every time you should be getting a different Bible verse. Cool. So that is how. So we basically did some sort of simple logic we've added. Now we'll just go through or talk more about this event. What does that event object contains? So I'm just using the Amazon provided documentation from GitHub. So this is how an event structure looks like. So you get information like what method did the user hit, and what endpoint was he trying to call. Other information like user agent, from which browser did the request come. So sorry, this is where you get the information about your HTTP call. What protocol version, what is the source IP of the user, stuff like that. So my whole point is that this event, whenever your function is called, whenever a request comes, this AWS is actually injecting this this information in this object, and then you write your business logic around it. So let's change things a bit. So what we'll do is, so if you look at this event structure, you can see that there is a key called request context. Under that we have HTTP. Under that we have source IP. So we'll just change this function so that it returns the IP address of the person who's calling it. So all we need to do here is we already have access to
Sorry to interrupt.
Yes, Bina.
How did you get what did you click to get that JSON structure? Yeah.
This is actually documented by AWS. You can either access the documentation, or this is also available in their GitHub developer guide.
Oh, okay.
Yeah.
Thanks.
Yeah. Or another approach is you simply print it here, and then you can understand what is coming.
Okay.
So for example, I think we could return back take the event object and simply return it back. That could also work. Let's try that. So we just deploy the change, and so now you get that JSON. This is the event that AWS is injecting. This is the same as the one that we saw in the documentation. Cool. So so our original intention was we want to return this API should return the IP address of the client. That is our goal here. So from the event object, we are just going to extract request context, HTTP, and finally, if I remember correctly, it is source IP. So let's copy that and return it. So this is pure event as a JSON or a dictionary, a Python dictionary. So we're just accessing that field. So now we deploy this change. And the next time people start hitting this, we should start seeing. So I'm seeing my IP address. The same thing should happen for you, for the others. So you should be seeing your IP address as a response. Cool. So that's about the demo. So the key takeaway here is, I would say, one is the runtime, where whatever cloud provider you use, they expect you to have a particular function or present as your entry point, so that they know where to inject the event and context, and the function that you provide should match their signature. Only then that integration works. So typically what happens is this: you have the structure, and from the event you figure out what type of call it is, and then you have business logic in a different package. You invoke it, some your service layer, etc. All the programming best practices that we do in normal methodologies. So cool. So now that was the demo part. Just wanted to show how the experience, how to play with this, and get more insights here, just to get hands dirty with it. So I'll just show a real world example. So it's more than a real world example. This is a real world architecture, I would say. Probably I can zoom it a bit. So this is I'm again, all my examples are around AWS, but it is valid for other cloud providers too. You will find equivalent solutions. So this is a popular pattern. So for example, think of I'm not sure if front-end developers are there in this call, React app. Say you're a React developer and you have a single page application, which is actually after it loads on the browser or users end, it makes a couple of API calls. Okay, that's a very, I think, recent pattern that we have seen. So what you can do, how to host this app's website in a serverless way, is that you can store your front-end React code or Angular code, whatever, in an S3 bucket or equivalent from whatever other cloud providers are providing. So that will host you'll have your static files there. So whenever the user hits your website, the code from this S3 bucket is loaded to the user's browser. And once the user's browser is rendered, or as part of the rendering, the React code can make API calls against API gateway, which will in turn call. So when I say API gateway, it's just that URL that we were using. So which will in turn call our business function, and our business function can return whatever is required. For example, it can talk to an external database like DynamoDB or a MySQL or whatever, and return back dynamic data to the front end, and React can display it. This is a very popular pattern. I mean, a simple popular pattern. There are a lot of other patterns too. So a couple of real world examples. I'm not sure how many of you are familiar with acloudguru.com. This is basically a training website for cloud technologies. So this entire website, this entire Acloudguru, the entire website is on serverless. They have 0 EC2 instance, I mean, servers running all the time. So it's like they are paying only for requests, only when people or students or users access their website. So everything, when the sign-in flows, also serverless. Another example is this is a Canadian-based company, not an e-commerce. They are most into similar to Dunzo. So this particular website is also purely following that architecture. So whatever you're seeing is actually React code, which is being served from a S3 bucket. And for example,
are you sure it's S3 bucket or it's a app hosting?
This is actually from an S3 bucket, friended with a CDN like CloudFront.
Okay, so you can actually have this kind of URLs straight away, serving content from S3 bucket.
Yeah, the only mandatory thing is you need to have a CloudFront, a CDN solution in front of S3. It's not shown in this diagram, but there is a CDN solution as well, like CloudFront or Cloudflare.
Okay.
Now to the so this is coming purely from S3 and CDN solution. And for example, I'm going to my profile. So if, for example, let's inspect this. So I'm just going to my profile page. Just a second. Yeah. Let's reload profile or task. So you can see these API calls happening. So this is going to a different domain, which is powered by API gateway. The URLs might not look very similar because we are using DNS there to have a proper URL. So the end point is, this is another example, a popular example for doing serverless. So with that said, we'll just go through, the benefits and the negatives as well. So the benefits, of course, is you pay for just the request. Not like a traditional world where you have to keep paying for your server even if people are not visiting website. That's not the case here. You pay only for the request, and it's actually very cheap. The reason why it's cheap is because if you think from the cloud provider perspective, they have thousands of servers and they have multiple customers using it, so it's efficient for them as well. Second thing is it's fully managed, so we can fully focus on our code. We needn't worry about deployments. We needn't worry about patching servers, or maybe there's a security hole in the API gateway software. It's all taken care for us. So fully managed also means managed security. And again, this is, I think, a duplicate point, but you can fully focus on your business. You needn't worry. This is really good for startups, I would say, when you're focusing on your product. You want to do some MVP on your product, so you can use such platforms. Now, everything is not good. There are drawbacks too. So the one major drawback is cold start. So to give some idea about what is cold start, it really goes back to the fact that we don't have a dedicated server at any point. So when a request comes in, the cloud provider is actually bringing up an instance of your application, which is then serving your request and processing your request and returning a response. So for example, one request comes. I'm making a call now. After half an hour, maybe the cloud provider could kill my application because it understands that there's no request coming. So it'll free that application from its servers and allocate it for other customers. So what cold start means here is whenever your request comes, there is a startup delay. So there can be a 500 millisecond or 1 second delay for the cloud provider to bring up your application. So that is what is called cold start. It is, if you compare all the cloud providers, Amazon has the least cold start. There are a lot of ways you can optimize and reduce it as well by following some best practices, but that is not in scope for the session. But that is a known problem with with the serverless technologies. The second drawback is vendor lock-in, which is if you look at these architectures, we are using a lot of cloud provider managed services or solutions, right? So to a great extent, you're getting locked into the ecosystem. But I would say I could argue the other way around also. If we structure your application properly, that is properly separate out your business logic as separate modules and stuff, then you could migrate to another platform. But there is definitely some additional work. It is not going to be very straightforward. The third point is from a cost. So this is not very much valid for small companies or medium scale, or even to a very large companies, MNCs. It comes into play when you reach scale of Facebook, Google, or Netflix. Then if you do the math, it will be easier for you to have your own servers and your own dedicated team handling the server side and things like that. Because at that scale, even serverless technologies become costlier. It's because we are paying per request, so it won't happen very soon. It's when you reach that scale. And another important one is the lack of support by legacy frameworks, or I would say more than legacy frameworks. For example, if you look at Java 8 or Java as a programming language as such, there is so Lambda does support Java. I think there are a lot of new initiatives in Spring Boot which supports or makes it compatible with Lambda. The only problem is it is not as performant as Python or any other runtimes. It's because Java uses a JVM. So every time a request comes, the cloud provider, your application takes time because it has to start JVM and then load your program. So there is more cold start problem happening. So Lambda supports it, but it is not very performant. That is one problem. And the other thing is developer tools. So when you're locally developing, like you might be like very much used to the old ways or old tools that you have been using for years. Those tools might not be compatible with this flow. But this is actually being actively worked upon. So almost all cloud providers are now providing developer tools for deployment, for debugging, etc. But not as mature as the existing tool sets that you might be using. Yeah, that's about it, team. So I was like, we can open it up for questions. I couldn't check the chat. Any questions, team? I don't see anything in chat. If anyone wants to unmute and ask any doubts or anything.
Yes, Arun. How different is this from Kubernetes and things deployed in that kind of ecosystem?
Yeah, Kubernetes is very popular. So I would say even in Kubernetes world, you are responsible for the infrastructure, like the EC, for example, let's the EC2 servers, right? You're still dealing with servers. Whereas in this
What about Amazon has its own Kubernetes cluster which is managed there.
Yeah, but still you have to have, for example, what if you have to take care of your worker nodes as well. There is something called managed node groups, but still the entry of you still have to manage a couple of things there. You'll have to have monitoring, maybe not from the cluster management level, but you are still responsible for deployments or making sure that Kubernetes handles it to an extent, but it doesn't provide this level of abstraction. There are
Is this architecture good for massive applications?
It is.
Big applications.
Yeah, I would say there are no. There is, for example, no the serverless technology, or for example, Lambda, I was introduced in 2016. But it started getting a lot of momentum from 2019, etc. So there are companies like Acloudguru, a lot of other companies relying on this. But I'm not sure it will. I mean, you can definitely run it on Netflix scale, but you will have to tune a lot of things. It should, at least theoretically, it should scale, but there are limitations.
I mean, managing the code base. Can we manage in the form of a project in this?
Yes.
So project with multiple modules.
Correct. It's all up to you. So this was just an example. So what you can structure the code however you want, and just upload it as a zip file into this platform. That is purely possible. That is all the way however we want to structure it, you can structure it. Suppose there are two Lambda functions and two API gateways to invoke the function. How does it map to the endpoint URL, that is API gateway to Lambda handler for invoking the right Lambda? Two Lambda functions, two API gateways to invoke. Okay, so to answer that, Nancy, in the configuration tab, we added a trigger, right? So when we created this function, we actually mapped an API gateway to this Lambda function. That is how that mapping is happening. Hope that answered it, Nancy. Just let me know, Nancy, if it didn't clear. We can go in deeper. Okay, next question is, in zip file also do we have to have the handler? Yes, we have to have the handler method. So if you're uploading a zip file, it should have everything. The handler method should be there. So for example, you might want to use a different handler name here. You don't want to use a Lambda handler. You want to call this main. In that case, there is a setting called runtimes. In runtime settings, you can define, what is your handler called. So you have to change it here to .main. So that is one way. But to answer your question, it should be there. That is the only.
Is there a CI/CD pipeline, right? Something that I push to the Git directly, it is picked up and built. Something like that is possible.
Out of the box, Lambda doesn't provide. You'll have to build it using other tools like either you can do it using Jenkins, you have to create it, or you have to use other services to
No,
do
but
that.
it will push to Lambda, right?
Yeah,
That possibility is there.
yeah.
And if we know, can we see where this is getting stored in the cloud?
The program code.
Yeah.
That is actually behind this. What AWS does is it creates a S3 bucket for you.
Oh.
And stores it in S3 bucket. When you do
So
it through console.
we can push it directly to that. Will it overwrite the project?
So if you directly push it to S3, it is not going to overwrite. So in this case, my function is very small, so that's why it's not there. But when you upload a zip file, right?
Yeah.
It will behind the scene create an S3 bucket and put it there. Or you can keep your code and push your code to an S3 and then specify the S3 bucket URL here. You can use object versioning as well. So whenever you can keep pushing to the same object and tell Lambda to deploy a particular version. Yeah, so Shashi, if we code in Java, it's main. Yeah, this can be handled. The only thing is you have to change your runtime setting and point it to your main function. Can we connect Lambda function to? Yeah, you can actually connect Lambda function to pretty much anything. It can be a DynamoDB, it can be a MySQL database, or anything hosted by some elsewhere also. So that case is supported today.
So if I am opting for Python and start, can I download this, and so whatever AWS generates, can it be downloaded and then developed offline, like the project structure?
Yeah, you can definitely do
just
that.
a simple one file that is there in the template. What about the dependency? Say if I want to add a Python dependency, or if it's a Node.js dependency, will it pull automatically from say like npm install or pip install? Is it done automatically in the background, or
no? So when you're I didn't touch that point, but when you're uploading your package, your zip file, it should contain all the
node
modules or any dependencies. Like you say you have a Python requirements.txt file. Those packages should be present in the package that you upload.
So if I am doing it here itself, so I want to add a dependency on the Lambda interface. I'm not doing development offline. So how do you do that?
In the Lambda interface, you cannot do. There are limitations today. So when you're doing through the inbuilt console, you can only use dependencies that are provided
already.
Yeah.
Okay.
Unless there is something called terminal. I don't think so. Ben. It should be uploaded. External dependencies. Any other questions?
Sorry, one question. So actually, if we try to build a small application, right? I mean, maybe for a shopkeeper or any retail website, is there some websites that we can host it, which anything built on React, Angular, or something else? I mean, with low cost, because maybe AWS may take some cost, right? So apart from that, is there any platform which enable free hosting of services where
So,
we can
mhm.
expect data in and out?
So there are platforms, for example, Netify. There is a website called Netify that you can use for for the use case that you specified. But Netify actually runs on Lambda. I mean, when you're creating, right, this is kind of an abstraction on built on top of Lambda and S3 and a couple of other technologies. But it just simplifies. What do you say? The experience. That's it. If say I'm not interested to understand a lot of Lambda or a lot of S3 terminologies and technologies, you can use something like Netify. From the pricing perspective, Bipin, I'm not sure. I haven't used this personally, but it's a popular option. If you want to be very cheap, I would suggest going with Netify is built on top of AWS, so they will definitely charge something. If you want to keep it dead cheap, it's easy to understand S3 and Lambda, I would say, and it is really cheap. If you check out the pricing, it's at least
Cheap,
for
is it in terms of, okay, this many requests per month, something
yep.
like that, or every month, is it like a bundled package, or uh, for every request it is billed?
Correct. It's actually for every request and how much time your function runs, the number of milliseconds. So
Oh,
so this is what we get for free every month. That is, you
oh,
get 1 million free requests per month. And after that, based on the region where you are, you might, for example, if it's hosted in US East, you will be charged $0.2 per the next million request.
oh, that's very, very cheap.
Yeah.
So, and then the S3 bucket also, typically how much I will need a dedicated bucket for this, right?
Yeah, you'll
And
need a dedicated bucket for it.
how does that come to? Sorry for asking, maybe
Hmm.
irrelevant. I mean, but it is just to get a picture of how much cost it will be incurred. How much will be the bucket costing?
Bucket costing actually depends on two factors. One is the size of your artifact, your website, which is very low. You can
Mhm,
ignore it for now for React bundles or a very low. The
mhm,
second thing is data transfer.
mhm.
That I need to check, but in my so far experience, I haven't been charged much for S3.
Okay. So
Yeah,
means many of these things may get even covered in the free tier. Is
yeah,
that
yeah. Yes. Entire thing gets covered in free tier. I mean, for a small scale, definitely. Only when you
okay?
start hitting say you're building a startup, you can
Mhm.
definitely build MVPs, everything, and say overnight you're a success, then you might start seeing spikes.
Okay. Okay. And the cloud front or something you
Yeah,
mentioned, is
yeah,
it a service available in
yeah.
AWS itself?
Yeah, it's a service. It's nothing but uh, a CDN.
Okay.
Yeah,
Mhm.
you can it's a service. This is also so the whole point is if your bucket is in US and you want to
Mhm.
keep the performance of your website, loading speed for your website good for India,
Everywhere.
then you
Mhm.
can use Cloudflare.
Mhm. Okay. So if I'm targeting all the customers from India, I can keep an Indian bucket, and even um, I mean, I don't need a CDN in that case, right?
You will actually still need a CDN because when you expose it to your end users, you want to give a good URL, right? For example, like
Right.
this. So
Okay.
to get
Okay.
this custom URL with SSL, you need CloudFront. S3 doesn't allow it today. You'll have to use the Amazon provided bucket name, which is
Okay.
weird for customers.
Okay. Fine. Thanks. I think it answered all my queries.
Um, Rincy, I think we are done.
So this can be any kind of thing. It can be even a data processing job also. Right?
Yep, correct.
So that will, what if it requires some good compute also? Like say for example, I need to process a file which is 4 GB size. Okay, so but I am writing a Lambda function on it. So it will be covered in the time required to process that request, and how can I scale this up if I want more faster response than what I am getting from the default.
Yeah, so typically you can do data pipeline data processing, but if it's very huge, you can chain Lambda functions. So for example, your Lambda function, you can have a NFS file store shared between Lambda functions, or you can have your depending on data, whether you can keep it in S3, loaded from S3, stuff like that. But it is not very straightforward, but there are ways around it. There are something called step functions in AWS, wherein you can do such kind of heavy workflows. But it is not very performant, or it's something we'll have to try and see. I personally don't have much experience in that line, but there are some workarounds and services for it.
Thank you.
Anyone else?
Can we use an existing domain name which I am having and use it on this CloudFront?
Yes, you can.
That's it from my side.
Okay. Okay, then. Thank you, Arun. It was really informative. And on behalf of Tech Ministry, I would like to thank you all for participating. As well, I invite you all to be a part of this Tech Ministry, to use your skills for God's glory and to help others. You would have received a link in your chat box. If you have any feedback, please put in. Also, if you'd like to join or if you have any queries, please at gmail.com. It's also in the chat box. So thank you all.